Okay, we're in section 24, Taylor series, stuff that we've partially covered already. We certainly did the Taylor series before and the general pattern for it. You know, degree 1 Taylor series, degree 2 Taylor series. These are ones that are centered at C. Degree N Taylor series, and then the series itself. That's the infinite series. We have shortcuts for this. The shortcuts are things that you know about. For example, you should know what the series is for the geometric. You should know the series for e to the x. Maybe you don't know this one yet, but we'll talk about it. I may not go through all the work over here, but this is a review of what you've done in the past. All right, you've actually done this in the past. We'll look at examples. Let's see what else we'll be doing here with the lecture. I guess we'll be doing one for sine too. Stuff that we've done in the past, by the way. I don't know there's any real reason to repeat that, but we'll go through it pretty quickly. You know, cosine, we'll do that one pretty quickly. Let's see what else. E to the x quickly, cosine. Yeah, basically we'll derive new series, but knowing old series. Again, it's just lecture portion. I'll go to the whiteboard later. We'll do some integrations, blah, 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 blah. All right. So I say after that lecture, I think probably you'll be exhausted, but you know, there's series that you should know about. For example, the geometric covered in Math 120. You should know about that series. E to the x, you know, after this lecture, you should be more comfortable with that series. Sine x, more comfortable with that series. Cosine x, more comfortable with that series. We've actually derived the arctangent before, but you may not remember that. That might be a tough one to remember. But again, if you need jogging, you can always go back in the notes and look over that material. We've actually derived this one in the prior section. This one over here, I'm pretty sure we derived that in this section. General binomial, a little more difficult, but it is something that's important. It's going to pop up. All right. So I'm going to say if you're going to walk away from today's lecture, I would say 1, 2, 3, and 4 should definitely be known. All right. The other ones, you could probably derive if you have to. All right. So I'm going to go whiteboard and I'm going to go back to the beginning of the lecture. We'll complete the lecture out and then we'll do more examples when we get there. All right. So let me go to the whiteboard. Let me get the whiteboard going for you. And again, part of the reason we give you notes is for you to study the notes. All right, so this one over here, we've done Taylor polynomials before. We've also done infinite series. So let me just review what we've done before. We've talked about Taylor polynomials and the series. We talked about that. What did we do? We talked about fitting degree 1 polynomials to a curve, and we came up with this form over here. We talked about degree 2 polynomials, fitting it to a curve, and we came up with this statement over here. And again, this is for a function f centered at some value c. Stuff that we've done before. Degree n, what's nice about these guys here, they've got really, really nice patterns. So nice, in fact, if you go through a certain number of terms, you start to say yada, 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 and you can go on forever and ever and ever. So this stuff has been covered prior, but we have shortcuts. And the shortcuts are going to be known series. We have known series. For example, this is a known series. This is a known series. And it's nice if we know those things, we can reuse those. All right. Now, you may not know these things yet, but we've covered these things. All right. You just may not know them yet. You may say, I can't remember any of that. All right. Where'd you cover this one over here? This is the geometric. I'll write that down for you. This is the geometric. And how do we do this? We did this a while back when we first introduced Taylor. How do we do that? Slowly, but we did it. All right. What do? We started fitting a quadratic and a cubic, and we start to say yada, yada, yada. Over time, it looks like it's fitting it beautifully. All right. So what are we going to do now? We're going to next page. And for example, this one over here, and I'm claim over here is they got another series. They probably say you should know this one over here. And you know what? Maybe you should. Maybe you should know this one. Whoops, sorry about that. What I'm going to say later on, we're going to derive this one in the lecture. All right. So, you know, the bottom line is they just keep yammering on about this Taylor series thing. All right. They just keep yammering on about it. So let's take an example that we've done before, and let's do it. All right. So if we're going to do this one, but I got to be honest with you, if I know this, why would I do it? Why would I do it again and again and again? There's no need to. So if I know this over here is this, oops, sorry, I made a mistake already. And I kind of know this, by the way. I'm going to say this is 1 over 1 factorial. This is actually x0 over 0 factorial. And I can write this down as a sum where n starts at 0, goes to infinity, x to the n over n factorial. Its interval of convergence is it's all real numbers. It's really covers everything. So how would you do that? Well, I want to remind you, the easiest thing to do is write down a really simple statement, which is what we did with the Taylor series before. So e to the x. What's nice about this one over here is the derivatives are super simple to write down, and you could do this all day long. Now, what's a nice number to center at this? I'd say x to be 0. So what do? You evaluate these things at 0. And what do you get? Well, e to 0 is 1. F prime evaluate 0, 1. F double prime evaluate 0, 1. F triple prime evaluate 0 is 1. Every single derivative evaluated at 0 is going to be 1. And then you write the Taylor polynomial down. Let me remind you, Taylor polynomial looks like. It's going to look like f evaluated at 0. This is centered at 0, by the way. F prime centered at 0 times x minus 0. I'll just put down x over 0 factorial. No, I'm not going to put that down. I'm sorry, over 1 factorial. Next one's going to be f double prime, 0 times x squared over 2 factorial plus f triple prime. You get the idea. X cubed over 3 factorial. What's nice about this? They're really easy to write down. 1 plus 1x plus x squared, because f double prime value adds to 1, over 2 factorial, plus x cubed over 3 factorial, yada, yada, yada. Again, the sum, we just did it before, n equals 0 to infinity, x to the n over n factorial. All right, and it's good for all real numbers. So I'm going to say, if you have to jog your memory, what we've done in the past, jog your memory, get it. Make sure you understand that one. I don't want to have to keep deriving that over and over again. And you shouldn't want to have to derive that over and over again. I could say it's probably the most important series you got. It's super simple. All right, let's go to the next page. Next page goes through a bunch of work. And then they ask you to do the sine one. Let me put the sine one down. And again, I'm just going to quickly review the Taylor. So what's f of x? It's sine of x. And what do you get over here? I'm going to say f prime, should be simple, cosine of x, f double prime x. What's going to be what? That'll be minus sine, right? This is more difficult, f triple prime. And what do you get there? Well, you get minus cosine of x now. Then you get 4. So this is why you keep going. Well, I want to get a pattern. And what's the next one going to be sine of x? So what do I realize? The wheels on the bus go round and round. Well, that's what we always say with trigonometry. So when you get to the fourth one, you're really back to the function. All right. So let's write this down over here. Should be relatively simple to do. So it says, why are you choosing 0? It's easy. That's why I'm choosing it. Are there other easy values for sine and cosine? Yeah, there's a ton of them. But 0 is like our preferred one because it's so easy to do. Write this down. This will be 4. What do you get over here? Well, let's see, what sine is 0? 0, 1, 0, minus 1, 0. So I get that pattern. So let's write this down. Sine of x equals f of x. That's what it is. Well, it's f of x. Of course it is. What do? Let's write the Taylor down. And again, we're getting a little better at this. So what's going to be, 0, that's the first term, right? Plus 1 times, well, it's going to be x minus 0. I'm just going to put x down, divide by 1 factorial, plus 0 times x squared over 2 factorial. All right, let's keep going. It'll get more difficult. Plus, well, now it's minus 1, right? X cubed over 3 factorial. I think you get the idea. All right, let me write this one down for you. What's it going to be? x minus x cubed over 3 factorial. And I think I got an idea what's happening over here. Interspersed with zeros, alternating. So what do you get over here? The fourth one would be 0. So then I'm going to put down the fifth one. That would go plus minus over 5 factorial, yada, yada, yada. All right. So x7 over 7 factorial plus x9 over 9 factorial minus yada, yada, yada. So let's write this down. So sine of x, its power series expansion, is going to be the sum. I'm going to write this down, and I'm looking at the, I'm going to say they're all fractions, and the bottom numbers are factorial, and I'm looking at it, and I'm wondering what that looks like, 3 to 5 to 7 to 9. That looks like 2n plus 1 to me, where n starts at 0, and this is a factorial, and it goes off to infinity. It's alternating, starts out as positive, and then I get these powers over here. What's power going to be? Let's see if I can put that down. I don't know if I can do that. So let's see, 0, 1. You know what? I don't want to start at 0 because 0 would give me, oh no, 0 is fine. I got to wonder about this one. Oh, you know what? I made a mistake. I didn't cut. That's why I was looking and saying this is not working out. That's an X. I'm sorry about that. All right. I'm really sorry about that. So it does work out. So it's going to be 2n plus 1. Let's take a look at that. Do I get what I expect? Minus 1 to the 0 is 1. And 0 would give me 1. X to the 1 is fine. And yeah, this is 1 factorial. Then you get 3, so and so on. All right. So what I would claim is that one probably should be known. So well, I'll just keep deriving it over and over again, but it should be known. All right. Let's go to the next page. And this one says cosine. Well, you know, cosine is also easy to do, but I guess I should know cosine. But let's say you didn't know it. It's easy to derive. So f of x is cosine of x. Start writing down derivatives. We're doing the Taylor polynomials. It's going to be minus sine x, f double prime. And there's a pattern to this as well. That's going to be minus cosine of x, f triple prime. That's going to be what? Sine of x. And then we're back to the beginning, which would be cosine of x. And like we say, the wheels on the bus go round and round. What are we going to do? Center it at 0 because it's easy and convenient. You could center it at other numbers, but f is 0, f prime is 0, f double prime is 0, f triple prime is 0, and f4 of 0. And these are really easy to write down. 1, 0, minus 1, 0, and 1. And again, the wheels on the bus go round. Was it going to be 1, 0, minus 1, 0, 1, 0, minus 1, 0, 1? You get the idea. So let's write this down. So f of x, again, is cosine of x. And we're going to write it down now. What is it going to be? Well, it's going to be, let's see, 1 x to the 0 over 0 factorial minus, well, I don't have any linear ones, but I had a quadratic. So it's what's going to be? It's going to be, 1 times x squared over, let's see if I did that right. 0, 1, 2. Yep, I'm at 2 over 2 factorial plus, let's see, that would be 0, but then I go to the next one, plus 1. And let's see, that would be 4, right? x4 over 4 factorial. I think I get an idea now. And let's write this down. And it's a series expansion. So I'm going to put down n equals 0 to infinity, 2n factorial on the bottom, x to the 2n, we'll check it later, minus 1 to the n. Does that give us what we want? Let's take a look. When you get alternating pattern, 1 minus 1, 1. Yeah, you get that. And the power is going up by 2. So 0, 2, 4. Yep. And the bottom is 0, 2, 4 as well. So this is good. This is true for all real numbers. Well, you know what? That's a nice one to know. And it's written over here. And that's a nice one to know. All right. So again, a little general pattern, pretty easy to do. All right. But again, it's tedious. It really is tedious to do it that way. It's nice if you had some ones that you know and some other techniques that you could derive ones from what you know. Look at the next page. And, it says we've got these three over here now. That's good. It says from these three, I could do this thing without going through that nightmare. So someone says, what do you mean by that? Well, if someone gives me x squared times e to the x, and they say, what's the Taylor expansion for that centered at zero? Well, what do I know? I know it's x squared times e to the x. And what's e to the x? If you can recall, hope you can, we just did it. Now, when I do this, I say yada, yada, yada. I'm saying it's obvious where it's going. Now, I need to multiply it out, though. What do you get? X squared plus x cubed plus x4 plus x5. And I'm saying they're pretty easy to predict. 3 factorial, 2 factorial, 1 factorial, 0 factorial. Let's write this sum down. We'll check it with the key later. And I'm going to say n equals 0. Oh boy, I got troubles, don't I? Let's look at the bottom first. 0, 1, 2. Oh, that's not so bad. That's just n factorial. This goes off to infinity. And the top is 2, 3, 4, 5. Well, that looks like x plus 1. I'm sorry, n plus 1. All right, let's take a look and see how we did. And I'm sorry, I made a mistake. It's n plus 2. And I should really probably check. But someone said, how'd you know that? I looked at the key. I realized I wasn't thinking. And that happens. And that's the whole point of when you start doing homework, you're going to see me make mistakes. Say, oh, gee, I hope I don't do that on exams. And I hope you don't do it on exams. I hope you clean that up. But again, you get credit for your work, but you wouldn't get full credit unless you put it down right. Let's just check it because I did say it should be checked. If I did 0, I get 0, 1, 2, 3. Now, if I did 0 on top, what do I get? 2, 3, 4, 5. So this is true. All right, that's good. Let's do the next one. The next one says e to the x times sine x. That's nightmarish. So I'll be honest with you. If they ask me to do e to the x times sine x, but again, I'm going to claim over here, if you do this by derivatives, you're losing sight of what we're asking you to do. We're asking you to look at it and write it down and realize it's a product of two series. And I'm not saying it's easy, but I'll write it down for you. And by the way, I don't want to write a bunch of terms down. And this might be tough to do, but I'll write this over here. And what do you get? Maybe I should put dot there. I just go on, right? Get my eraser out. I think you get the x cubed over 3 factorial. At some point, I got to say yada, yada, yada. I can't just keep writing that forever and ever and ever. And then what sine x? Well, I think I can remember that. That was x minus x cubed over 3 factorial plus x5 over 5 factorial. Let me just put one more term down. Minus x7 over 7 factorial. And then, yada, yada, yada. All right. Now, by the way, I'm not claiming it's easy to do. I'm going to do the multiplication. And I make mistakes. So I'm going to look at my key later. So what's 1 times that? I'm using the distributive product multiplication. It's going to be x minus x cubed over 3 factorial plus x5 over 5 factorial minus x7 over 7 factorial. And yeah, it goes on forever, but I can't go on forever. Now I'm going to do x times that. What are you going to get? Well, x times x is x squared. And then what do you get? X times x cubed is minus x4 over 3 factorial. And then x times x5 is x6 over 5 factorial. I think you get the idea, right? And then what do you get? If you did it, you get x8 over 7 factorial. All right, I got to do this one. It's trouble for me. I'll be honest with you. What do you get over there? Well, that would give you x cubed over 2 factorial. Oh boy. Then you get, let's see, not plus, you get minus, sorry about that. Minus x5 over 2 factorial, 3 factorial. Gee, that's crazy. And then you get x7, 2 factorial, 5 factorial. I don't know if I want to go much further. Let's do that x cubed now. What are you going to get? And again, these go on forever. And forever is the definition of hell. What do you get next? Let's see what you get there. I'm doing x cubed now, right? So you get x4. Let's see if we did that right. X4 over 3 factorial. Let's see if I said that right. Yep. And then you get x6. That 3 factorial, 3 factorial. And then what do you get? Well, I guess you get the x8, right? I don't know if I want to go out there, but that's going to be, I think I might have made a mistake somewhere. Let me just take a look because I'm saying, I'm sorry, I made a mistake. I had to erase it. This is why I really hate doing this because it's so much nonsense. The machine can do this really quickly. And then you get plus, I guess you get x8, 3 factorial, 5 factorial. All right. Now, granted, I'm not saying I can't make mistakes still. I'm going to try to put this down here. I can't write all the terms down, but what do you get? I guess you get x, right? And you get plus x squared. Got this. Now I got to do these two. Let's hope I didn't forget anybody. Boy, that's a common denominator, isn't it? So that's going to be 2 and 6. 6 would be a common denominator. So 3x cubed minus 1x cubed, which is 2x cubed over 6, which is going to be plus x cubed over 3. These cancel. Let me do this. Boy, I hope I don't make a mistake because I'll have to do it all over again. Cross this out. Well, 5 factorial is 120. That's x5. And then minus, well, it's 2 times 6, which is 12, x5, 120. That's x5 minus 10x5, which is minus 9x5 over 120. And that's going to be minus, let's see, minus 3x5 over 40. I really hate these. I kid you not. And certainly I hate to torture people with them, but I want to look at it. And so what are you looking at? This thing. Oh, by the way, I did do this. Give me 1 second. Okay, let me take a look what I got. This, I got this, I got this. I think I made a mistake. I made a mistake over here. I got to look at it again. Where'd that mistake come from? I don't know. Take a look. It's that 5th guy, right? And did I make a mistake somewhere? Let's take a look. And you know what? I really screwed up my board here, didn't I? That's a problem with this whiteboard. When I move it around, sometimes things move with it. But 120. Let's see, 5 factorial is 5 times 4 is 20, 60, 120 x5 minus x5. And that's 2 times 6 is 12. So that's going to be 1 minus 10 minus, it can be minus 9 over 120 x5. I hate to do it to you. I got to do it again. I made a classical error somewhere on that term. And by the way, what term did I get? I hate to do it to you. I really do. But I got to do it. I got to do it again. I got to be more careful. And let me be more careful this time. All right. So I'm just going to multiply it out now. And let's see what we're going to get over here. Oh boy, that's tough. So let me write this down. Be more careful now. Oh boy. There's a point to this, by the way. No one enjoys doing this. All right. I'm going to multiply by the x. Well, I've already done all that. I'm really worrying about the fifth one, aren't I? So what would the fifth one be? That would be x squared 2 factorial times x cubed 3 factorial. Oh, let's see where that came from. I think I'm missing somebody over here, right? So there's guy over here. This would be x cubed over 3 factorial. And then you'd have plus x4 over 4 factorial. And I see it. I see what I'm missing. I'm missing that x4 times x over 4 factorial. That's what I was missing. All right. I'm just going to do this term over here. I forgot somebody. So it's really x5 over 120. And that's going to be minus x5 over 12. And that's going to be minus x5. I want to make sure I did that right. And x4, yeah. And then, wait a second. Yeah, over 4 factorial. What's 4 factorial? It's 4 times 24. So I put 120 down. And that's going to be x5 minus 10x5 minus 5x5, which is going to be minus 14. Hope I didn't make a mistake again. And I think I made a mistake again. Where's that? There's a point to this. I'll get to the point in a second. Say x4. I'm sorry, it's plus. So it's going to be 6. Let's see, minus 5. Oh, minus 4. I'm sorry. It's tedious, all right. So what's that going to be? Minus x5 over 30. All right. Now, again, if you think again, we did the first 3, we did okay. I started to make an error over there. Just imagine what these would be like. So what I want to do is I just want to, go to a program. All right, just give me 1 second to do so. I'm going to stop this share. And just give me a second. And a new share, desktop. And let me just see if I got a terminal open. Nope, I got to open up a terminal. And I'm going to run Sage. And what I want to do is I want to just go to this problem that we had. Now, someone can say, well, I don't even know how to use Sage at this point because they really haven't been spending much time with it. And that's a problem people have. They say, I can't use things because I never even thought about I might need to use this someday. Well, someday comes sooner than you think. And, you want to be able to do a Taylor series. So someone's going to say, well, I don't even know where that would be in the notes. And I got to be honest with you, it's got to be somewhere. Right now, certainly someone says, where would it be? My notes are highly structured, by the way. And typically, where does that stuff occur? It occurs towards the end of the notes where you would get something that would tell you how to work Sage. Like there's homework. Yes, I know this seems long to you. There's homework. You go through that. Yeah, you do, all kinds of neat stuff with the homework. That's just practice. And then after homework, what do you look at? You're going to be looking at Sage Code. I know people say this is too much work. I can't do all that work. I got more important things to do in life. And I'll be honest with you, at this stage of your life, there's nothing more important than being able to become educated. So what I want to do is I'm looking at the code now. So what am I going to do? I'm going to write this down. And what do I see in the code? All right. And someone says, why would you scroll there? We're trying to teach you to do that. All right. So let me write this down. Taylor. All right. And then what I'm going to do is I can put down, what was the Taylor series? It was e to the x star sine of x, right? X is the variable. And we're going to start, I'm not going to start. We're going to center it at 0. And I want to go out, I don't know, 10. Let's see what happens. Now, remember this. If I make a mistake, the machine's not going to blow up, right? Now, someone said, what did it just do there? It computed the Taylor polynomial. Now, what I want to do is I just want to go back over to the notes. And someone could say, well, didn't you just show us this at the board? And you were struggling with the arithmetic and multiplying it and things together. Yeah, at some point, you got to say to yourself, I better learn how to use a machine to do certain arithmetic or certain mathematics. So let's go back to that problem. I know it's tough. Got to find it, right? Where was that? 342, right? Okay, let's look at it. Suppose I wrote it backwards. I do see the x, then I see the x squared. I see 1/3 x cubed. I see my minus 1/30 x fifth. That looks pretty good. Then I see minus 1/90 x 6. I do see that. It's going backwards. I realize that. Minus 1/630 x 7. Yep. And then this one over here, even further. Now, someone says, I wonder if I could go out even further than that. Go out as far as you like. All right. There's 100. Watch this. It computes it. That would be a lifetime sentence to most people to come up with that. A lifetime sentence. And I can almost guarantee you they'd be making mistakes along the way. All right. What does that do? That did it really quickly. If I had to do that, again, it would be a lifetime sentence. I don't want to do it. Now, could I do some? Yes. Could I do that out to that level? No, I can't do that. And you can't do it either. All right. Let's go back to my whiteboard. And the point of that was, yeah, that multiplication was different. By the way, if you think multiplication is difficult, you should just see how bad the division is going to get. It gets even worse. All right, maybe even worse. So let's take a look. I'm going to go back to another share, back to my whiteboard, and give me a second. Okay, so we talked a little bit about using software. All right, and yeah, mistakes happen. They really do, especially when things get difficult. No one's like the tedious multiplication or division problem. Let's go to the next page. Oh, this one's a lot easier. I could carry this to infinite number of places. And why is that? Well, I'll be honest with you. The reason I can do this one so quickly is I know the cosine. I'm going to use the letter u now. And what's that going to be? 1 minus u squared over 2 factorial plus u 4 over 4 factorial. And I'm going to say a really easy pattern. So what's this one going to be equal to? 1 minus, well, it's not u, it's x squared now. So it's x4 over 2 factorial. And this doesn't really require much skill here at this point. That's going to be plus, what's going to be x8 now, right? Over 4 factorial, yada, yada, yada. As I say that, I want to write the sum down for it though. And let's see if we can do that. So I'm going to say cosine of x squared can be written as a sum problem. Let's see if we can do that. And again, it might be difficult, but I want to write this down. I'm going to start at 0. I'm going to go up to infinity. And the bottom appears to be 2n factorial. Let me go through that with you. So this one, let me put a fraction over there. That would be 0 factorial over there. So I'm going to say it looks right to me. So, 0, 2, 4. I see that. What else do I see? And we'll check the key later. I see that there's going to be an alternating pattern to it. So I'll write that down for you. So that's minus 1 to the n. And then what I get x to a power. And what power? Well, 0, 4, 8. So I'm going to say 4n. All right. So let's look at it. Let's look at the key, and we have that written right over here. All right, we have it written right over here. Okay, so that's done. That was easy to do. Now this one over here, it says we know. Well, it's true. We do know that. We know, simple integration. We know that. The integral of 1 over 1 plus x is the natural log of 1 plus x. By the way, most likely you put down the absolute value of x, but let's not worry about this stage over here. What I want to do is, if I know this, I'm going to use what I know about it. And so I know something about this over here. I know this too. So the question is, if you know this becomes a much easier problem for me to deal with. What is it going to be? 1 minus x plus x squared minus x cubed, yada, 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 dx. And I think I can do the integration. My problem with the integration, though, integrations tend to be quite difficult because they involve a constant of integration. We'll talk about that later. So plus, what's the antiderivative of 1x minus the antiderivative of x squared over 2. What's the antiderivative of x squared? And again, I'm hoping to see a pattern. That's going to be x cubed over 3, then minus x4 over 4. Hope you get the idea what we're doing over here. What goes on here? This goes on forever. I don't have time to go on forever. All right, so it comes to, how could you figure out what the C is? Well, I need to pick an easy number. And the easy number I'm going to pick, and again, I'm looking for easy, I'm going to pick x to be 0. And what would you get? Natural log of 1 is equal to C. And then every term after that would be 0. So what's the natural log of 1? 0. So what's C? C is 0. So I now found a series for the natural log of 1 plus x. What is it? X minus x squared. We'll look at the key later, by the way. Plus x cubed over 3 minus x4 over 4, yada, yada, yada. Let's write it down as a sum. Let me see if I'll put a 1 there, and I'll put a 1 there. And let's write this down. So what's it going to be? This is going to be equal to the sum. And again, I'll check the key later. N equals 1 to infinity, n, x to the n, and it alternates. And I have to put n plus 1 now. Let's see if we got it. And it's right over here. Let's just check it. Looking good. We did okay. All right. So that's, basically an introduction. I'm going to tell you again, multiplying series together and dividing series together can be a nightmare because they're infinite number of terms. We're looking for easy things to do. When things get tough, I'm certainly going to whip the machine out. Let's go to the next page, though. And the next page is going to be, maybe there is no next page. No, there's no next page. By the way, when I say there's next page is start the examples, and we'll start doing that next. I'm hoping the examples for the most part are easy, with the exception of the division of series and the multiplication series, which can be problematic. We're not trying to make your life a nightmare, though. All right. Thank you for your attention. Again, if you have questions or concerns, please bring them to my attention by coming by during office hours, and I'll be more than happy to help you. All right. Thank you.